In this video, we discuss learning outcome number 4 from lesson 6.2. Here we're going to find areas or probabilities, which are the same thing, corresponding to a range of z-scores. Now just recall that probabilities for a range of x values correspond to areas under a curve when you're dealing with continuous probability distributions. And the total area under the graph of that probability density function is always equal to 1 for a continuous probability distribution. Now, the standard normal distribution, which is the subject of this section, is a special continuous probability distribution. It's a normal distribution with a mean of 0 and a standard deviation of 1. But remember, areas correspond to probabilities. So if you're asked for the probability that z is in a certain range, they're asking you for the area under that curve. So this lesson, or this video, excuse me, is about how to find probabilities associated with normally distributed variables. So suppose somebody gives you a random variable and they tell you it's described by that standard normal distribution. So the mean for that random variable is 0 and its standard deviation is 1. Then we can find areas or probabilities for different regions under that standard normal probability density function using one of two methods. We can either use technology, I'll show you how to use Excel to do this, or we can use table A2. Now, technology tends to be more accurate. You have more decimal places of accuracy. So Mr. Triola, the author of our textbook, strongly recommends using technology. And I would recommend using technology if you have to be especially accurate. But table A2 is what will be available during your exam. So I want you to get comfortable using table A2 as well. So here's how we use table A2. First, table A2 describes the standard normal distribution. You want to make sure you keep that in mind. It's not just a normal distribution, it has to be a standard normal distribution. So the mean must be 0 and that standard deviation must be 1. Now, if you're looking at a non-standard normal distribution, you can convert that to a standard normal distribution using some formulas that we'll talk about in lesson 6.2. So we can use table A2 and with non-standard normal distributions as well. We've just got to do some conversions first. Now, table A2 has 2 pages, one for negative z-scores and one for positive z-scores. Positive z-scores are those that lie to the right of the mean. If the z-score is positive, that means you're looking at the number of standard deviations above the mean. So if z was positive 2, you would be looking at 2 standard deviations above the mean. If z is negative, that's a number of standard deviations below the mean. We've got different pages for that, the negative z-scores and the positive z-scores. Oops. Now, when you're looking at the body of these tables, what you're seeing in the body of the table is this area to the left of the z-score. Whether you're looking at the table for negative z-scores or positive z-scores, it always refers to the area to the left. So if we want the area to the right, we're going to have to use the area to the left to infer the area to the right. And if we want the area between two z-scores, maybe from this z-score to this z-score, we're going to have to use the area to the left to infer that as well. Let me actually show you table A2. This is what you'll have available to you during your exam. So we've got negative z-scores here on this page. And then we've got positive z-scores on the next page. Notice that in the body of the table, when z is equal to 0, so we'd go in this column and find z equals 0.0. And then to get that hundredths place, we would look in this column. So you're looking for this row that has the z 0.0 here. And then in this column that has the 0.00 for z to be equal to 0. Then the area to the left is 50%, which makes sense because the mean is 0. So the mean and the median happen to be 0. So 50% of z-scores lie below that mean, which is equal to 0. And then the other 50% lie above it. So when we're looking at positive z-scores, all of these areas, all these entries in the body of the table represent areas to the left of that z-score. All those areas are between that 50% and 100%. So we go from z equals 0.00, where the area is 50% right there, all the way up to z equals 3.49, because this column gives you the hundredths place. So this is with z equals 3.40, that's in this entry. That's the area to the left of z equals 3.40. So that's the area to the left of 3.4 standard deviations above the mean. Then we've got 3.41, 3.42, 3.43, all the way up to 3.49. Turns out the area to the left of 3.49 is 0.9998. That's how much area is to the left. And remember, and there's a total area of 1 under that curve. So anything above, any z-score above 3.49 has a probability that is less than 0.0002. That's pretty small. But all of these areas are between 50% and 1. And then when we're looking at negative z-scores, all the areas are between 0.001 and this 0.4641. So notice that you've got all of these areas over here between 0 and 50%, or 0 and 0.5. And then over here, you've got all the areas between 0.5 and 1 for our positive and negative z-scores. Okay, let's go back to the PowerPoint for a minute. Okay, this is a really important point. That's why there's a slide for this. You have to be really careful about confusing areas and z-scores. A lot of students do. So here's, let's just clarify. Here's a little bit of clarification. The z-score represents the number of standard deviations above or below the mean. So when you're looking at that standard normal distribution, the z-scores are on the horizontal axis. Now, if you're using that table A2 to find the z-scores are on the outside edge of the table A2. You're going to use that leftmost column to find the first 2 digits of the z-score. So you're going to get that whole number, that first place, and then that tenths place in that leftmost column. And then to get the hundredths place, you're going to go to that top row. So the z-scores are on the outside of that table A2. Now, areas and probabilities are on the inside of the table. And these will always correspond to area to the left of the z-score, not areas to the right, not areas in between. You'll have to infer areas to the right or areas in between z-scores. Now, again, these are values in the body of the table. Now, in this learning outcome, in this video, we are finding areas and probabilities corresponding to z-scores. So we're going to start on the outside of the table because we're going to know what the z-scores are, and then we're going to go to the inside of the table to find the areas and probabilities. Now, sometimes when you're doing your homework, they're going to give you that information the other way around. Rather than giving you a z-score cutoff and saying, find the area or probability to the left of this z-score or to the right of this z-score or in between these 2 z-scores, they might, instead of giving you the z-score and asking for the area or probability, they might give you the area or probability and ask for the z-score. So you have to be comfortable with both. Just remember, the z-scores are on the outside, areas and probabilities are on the inside. So let's look at that table again. The z-scores are on the outside. So if somebody told me z equals 1.75, I would go to 1.7. I'd be looking in this first column. I find the 1.7 row, that's here. And then to get the hundredths place, I have to look at this top row. I'm really looking for a column. If I want 1.75, I'd go to 1.7. And then this is the area to the left of 1.70. That's the area to the left of 1.71, area to the left of 1.72, and so on. 1.73, 1.74, 1.75. So the area to the left of 1.75 is this. It's that value right there. So it looks like the area to the left of 1.75 is 0.9599. So if I was given a z-score and I wanted to find the area to the left, I would look it up in the body of the table. Now, if somebody says, oh, the area to the left is 0.5199, what's the corresponding z-score? Well, then I would look for the area in the body, and then I would find the z-score on the outside. So just make sure that you're looking at the right thing. Z-scores are on the outside, areas are on the inside, and you want to be very careful about what the problem is asking you to find, and then what each of these numbers represents. These are areas and probabilities, and on the outside here, we've got z-scores. Okay, so let's do some examples. Oh, before we do that, this graphic just talks about the different types of technology that you can use to find areas to the left or areas between two boundaries. I'm going to show you how to use A2, table A2, and I'm also going to show you how to use Excel to find this cumulative area from the left. So that's the area that starts all the way out at negative infinity and goes all the way up to that z-score. So this is what you would find in that table. And I'll also show you how to find that same area using Excel. We can use StatDisk for that as well, Minitab, StatCrunch, all of those will give you that value, but I'm going to show you how to use A2, the table A2 in Excel. And if you have a TI 8384 plus calculator, you can use that to find the area between two boundaries. You can also use StatCrunch to find the area between two boundaries. I'm not going to show you how to do that, but if you have access to that, all you would have to do is search for normal probability area between two boundaries, TI 8384 plus calculator. If you just Google that, there are lots of tutorials about how to use the calculator to find these quantities online. But that won't be necessary in this class. You can just use table A2 or Excel. So let's do an example. This one is asking for area to the left. And let's read the problem statement. It says, oops, a bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis. The result of a bone density test is commonly measured as a z-score. The population of z-scores is normally distributed with a mean of 0 and a standard deviation of 1. So these test results meet the requirements of a standard normal distribution. So a bone density test result is a z-score. Okay, the first part of this question says, a randomly selected adult undergoes a bone density test. Find the probability that this person has a bone density test score of less than 1.27. In order to show you how to solve this, I'm going to share my paper with you. Okay. So they want the probability that the z-score, that test score, is less than 1.27. I always like to start these problems by drawing a standard normal distribution. So we've got something that looks like this. And remember, with a standard normal distribution, the mean is in the middle and the mean is 0. So another thing, or another way you can interpret this expression is to say, what's the probability that a z-score is less than 1.27? That's 0 standard deviations, that's the mean. If you want to go 1.27 standard deviations above the mean, and we want that area to the left. So we want this area right here. Now there are a couple of ways you can find it. You can find it using Excel. You can also find it using that table A2, and I'll show you how to do that. That's the question. What is that area? Because the area to the left of that z equals 1.27 is the probability that z is less than 1.27. And the probability that z is less than 1.27 is going to indicate the percentage or the chance that a randomly selected adult has a bone density test score that is less than this 1.27. In order to figure that out, let's use our table. So z equals 1.27 is positive. So I go to the positive z-scores. And then I go to this first column and I look for 1.2. So there's 1.2, and this is 1.20. This is the area to the left of z equals 1.20. This is the area to the left of z equals 1.21. That's 1.22, 1.23, 1.24, 1.25, 1.26, 1.27. So here we are. The area to the left of z equals 1.27, according to table A2, is 0.8980. So that is the probability that that z-score is less than 1.27 standard deviations above the mean. Or if you are testing a randomly selected adult with a bone density test, there is an 89.8% chance that adult will have a bone density test score that's less than 1.27. That's what that means. Oh, I forgot to show you this. It's okay. So let's look at some notation. This says P of, it looks like P of A is less than Z is less than B. This indicates the probability that Z is between A and B. This indicates the probability that Z is greater than a particular Z-score A. And the last one is what I just used. This is the probability that Z is less than A. In our case, A was 1.27. Now remember, the probabilities in table A2 are always probabilities of this last form. It's giving the area to the left of A, not the area to the right of A. In order to find area to the right or the area between two values, we're going to have to use the area to the left to infer those results. Okay, so we used table A2, and this is how we did it. We said, let's go to Z equals 1.2 in the left column, and then we go to 0.07 in that top row. And I was really just counting. I said Z equals 1.20, 1.21, 1.22, all the way over to 1.27. And that was because I was looking at a part of my table on the computer. But if I actually have that hard copy of the table with me, I would just go to the top row and find the 0.07 and then find out where that column and this row line up. And then that would give me the correct entry. Oops. So this is what you would see in that table. So you go to Z equals 1.2, and then the hundredths place is 0.07, and then you find out where that row and that column intersect, and in that entry you see 0.8980. So that's the probability that Z is less than 1.27, which can be represented graphically by something that looks like this. Now we can do the same thing in Excel. In order to use Excel to do this, we're going to use a function called norm.dist in Excel, and this is really nice. Now I've zoomed way in so that you can see what I'm typing. Here I just type equals so that Excel will bring up its functions, and then I start to type normal, and then norm.dist for normal distribution pops up. And then I don't know if you can see it, but down here it says that the variables, the values of the variables that you're supposed to enter are the particular X value, in this case, we're using Z values, the mean of that normal distribution, the standard deviation of that normal distribution, and whether or not you want the cumulative area to the left. So our Z-score that we're interested in is 1.27. Since we're talking about a standard normal distribution, the mean is 0, the standard deviation is 1, and we want to say true, yes. We want it to be cumulative, meaning we want the area to the left. And look, we get the same answer, approximately 0.8980 if we round. Notice we have more accuracy. We have accuracy out to 1, 2, 3, 4, 5, 6, 7, at least 7 decimal places. Not 100% sure about that 8 because it may be an 8 due to rounding. So that's why Mr. Triola recommends you use technology, because you've got so much more accuracy. But most of the time when you're talking about that probability or that area, you really don't need that accuracy. Table A2 is enough. But this is a method that you can use. If you have Excel on your computer and you don't have your table with you, you can always just use, again, equals norm.dist. Highlight that, and it actually tells you in Excel what those variables are. The X value, the mean, the standard deviation of the particular distribution you're talking about. And cumulative, you always want to say true, because that's going to give you the area to the left. Okay, so we type in the Z-score, the 1.27. We type in the mean of 0, the standard deviation of 1, and true. And then we round to 4 decimal places because that's what we had in our table. And we see that we get exactly the same answer. Okay. So the way we interpret this is that the probability that Z is less than 1.27 is the same as the area under the curve. So that value of 0.8980, that is the probability that a bone density test score is less than 1.27. It's also the shaded area under the curve. They are the same thing. They are exactly the same. It will always be the same if you're talking about the area under a probability density function for a continuous random variable. Now we can interpret that to mean that there is an 89.80% chance that a randomly selected person has a bone density test result that's less than 1.27. Or, oops, there's a typo there. Let me fix that. There we go. Or you can interpret that as saying that there's approximately an 89% or approximately 89% of people have a bone density test result that is less than 1.27. Okay, so that's how we use table A2 and technology, Excel, to find the area to the left. Now let's look at a question where you have to ask, or you're asked, excuse me, to find the area to the right. It says using the same bone density test, so it's still normally distributed, and it's a standard normal distribution with a mean of 0 and a standard deviation of 1. Find the probability that a randomly selected person has a result above -1.0, which is considered to be in the normal range of bone density readings. So we want to say, okay, we get a result back. What's the probability that that result for that particular person is normal? It's going to be normal. What percent of people have a bone density that is considered normal? We can find that using our understanding of standard normal distributions and the table or technology. So in order to solve this problem, I'm going to share my paper with you. This time they said we want the probability that the Z-score is more than -1.00. And that means that the person has a normal bone density test result. So I'll draw a normal distribution. The mean of 0, that's in the middle. And we're looking at Z equals -1, that's right here. That's 1 standard deviation below the mean. Now we want the probability that Z is more than that. So we want this area over here. but our tables don't give us area to the left or area to the right, excuse me. They only give you area to the left. But it's easy enough to find area to the right if you have area to the left. Because remember, the total area under this curve is 1. So if I know what this area is 1 minus that area. So if this was 0.3, this would be 1 minus 0.3 or 0.7. This was 0.2, this would be 1 minus 0.2 or 0.8. It's just like complements. If this is 30% of the area, this is 70% of the area because the total area has to be 100%. So this is what we're going to do. Since we don't have area to the right in our table, we'll take 1 and we'll subtract the area to the left. And that's going to give us area to the right. In order to do that, I will bring up my Z-scores again. I'll bring up table A2. So let's zoom out a bit. Now, Z equals -1 is in our problem statement, so I need to be in the table of negative Z-scores, not positive Z-scores. So I'm going to go over here. Z equals -1.0. Okay, so according to this, oops, the area to the left of -1.0, can you guys see it? I hope you guys can see this, is 0.1787. Or 0.1587, sorry about that. I don't know if you were able to see that. I don't think I was sharing my screen. I'm sorry. I was looking that up in the table on my screen and I didn't share my screen with you. Let me share my screen now. Here we go. Sorry about that. There's Z equals -1.0 and there's the entry in the table. So that is giving me the area to the left of Z equals -1.00. And that's what I wrote here. So if I want the area to the right, I just subtract that area to the left from 1, and that's going to give me the area on the other side. So you have 1 minus 0.1587, which equals 0.8413. And that's it. That's the area to the right. So if I'm interpreting that as probability, I would say the probability of somebody having a normal bone density test score is 84.3 or 84.13%. Let's go back to the PowerPoint now. Okay, so we're looking for a area to the left, or we knew we wanted the area to the right. So we go to the table. Z is -1. That's the boundary in question. So we go to the page with the negative Z-scores. We look up the area associated with Z equals -1 in the table. Find the area to the left. And then you want to find, if you want the area to the right, subtract. Area to the right is 1 minus area to the left, which is that 0.8413, which means 84.13% of test scores, bone density test scores, are considered normal. And that's a graphic for that. Now, we could also do the same thing in Excel. Let me show you how we would get that same value. We'll type equals normal distribution. And it doesn't really matter the case. You can use uppercase or lowercase letters. We want Z equals -1 for a mean of 0, standard deviation of 1, and we want true for cumulative. That means we want the area to the left. So this is the Z-score, the mean of that normal distribution, the standard deviation, and then true for yes, we want cumulative area to the left. So hit enter. and we get that 0.1587 approximately. That's the same value that we saw in our table. So you can use that if you want to, but again, Excel is also giving you area to the left. So you would still have to find that value and then subtract it from 1 to get the area to the right. Okay. Now, lastly, you could be asked to find the area between two Z values. So this is another application of these bone density test scores. Scores between -1 and -2.5 indicate that a subject has osteopenia. I may be mispronouncing that, excuse me, which is some bone loss. So if somebody has a score between -2.5 and -1, then they have some bone loss. The question asks us to find the probability that a randomly selected subject has a reading between those two values, or in other words, find the probability that one of the people coming in for this test has some bone loss. We want the Z-scores to be between -1 and -2.5. So I'll draw a picture. Here's Z equals 0. Z equals -1 is there. Let's say -2 is there. -2.5 would be out here. So we want the Z-scores in between -1 and -2.5. So we want this area right here. I think I said the Z-scores in between. Yes and no. We want the probability that a Z-score is between those two values. And the probability is that area. Now, again, I want to go from smallest to largest, so -2.5 to -1. I don't have areas between two curves in my table. I only have area to the left. So if I want area between two curves, all I have to do is take the larger area right here. That's the area to the left of -1. So it's the probability that Z is less than -1. And then I want to subtract the area to the left of -2.5. I want to subtract that little piece. Now, a lot of students will try to memorize a formula. They'll try to say, well, the probability that Z lies between A and B is the probability that Z is less than one of those minus the probability that Z is less than the other one. I actually don't have that memorized at all. I look at this picture every time, and I highly recommend you do as well, because that is much more insightful than just memorizing some formula. I want this larger area, which is the probability to the left of -1, minus the smaller area, the probability to the, which is the probability corresponding to the area to the left of -2.5. So I just need this and this. We can look both of those up in the table if we want to. So let's try it that way. Oh, actually, before we do that, well, no, that's fine. We've already found the probability that Z is less than -1. It was right there. So the probability that Z is less than -1 is 0.1587, according to the table. And now we want to subtract the probability that Z is less than -2.5. Oops. Let's clear that drawing. -2.50. So it's -2.5, and in the hundredths place we want a 0. For some reason, it's not letting me draw this time. Oh, there we go. I want to draw. Negative 2.50 is right there. The area to the left of negative 2.50 is 0.0062. Okay. So I've got this area minus that area. I subtract those and I get 0.1525. That's the probability that Z lies between those two values. And because those Z values correspond to bone density test scores, and bone density test scores in this range indicate that osteopenia, then this is the probability that a randomly selected person will have evidence of osteopenia based on that test score. So there's a 15.25% chance that a randomly selected person will have a score in this range. Let's go back to our PowerPoint. So we found that area, and then you subtract them, and you get that 0.1525. Now, before we go on, I want to show you that you can do the same thing using Excel. Remember, this is the area to the left of -1. Let's find the area to the left of -2.5 now. So I use that normal distribution function. I said you have to put equals there, equals norm.dist, and then open parentheses, -2.5, that's the Z-score. We're talking about a normal distribution with a mean of 0 and a standard deviation of 1. That's what they ask for, the mean and the standard deviation. And then for cumulative distribution, do we want the area to the left or not? We say yes, we want the area to the left. So we're typing true to say we want the area to the left, equals. And then the area in between is this area minus, oops. Do this area minus this area. And we get 0.1524, which doesn't quite agree with us. We had 0.1525, but that's just due to rounding. So this is slightly more accurate, the answer we got in Excel, but this is the answer that we got using the table. And either of those will be fine for your exam over this material. Now again, you're just finding the difference between the two areas. You're taking the larger area and you're subtracting the smaller area to find the area in between. I highly recommend that you understand that intuitively, like you understand the concept rather than trying to memorize a formula. So what I would do is I would draw that area, make sure that you list the two Z-scores on the number line in the correct order. Z equals 0 is in the middle. The farther you go to the left, the larger in magnitude those negative Z values become. And as you go to the right, your Z values are increasing. So write those on the number line. Then you will be able to see just from your picture where that larger area's cutoff is and where that smaller area's cutoff is. And then you'll just take the difference, the large area minus the small area, in order to get the area in between. Okay, so this is just a reminder of what we were talking about at the very beginning. Continuous probability distributions, or when you're talking about continuous probability distributions, the probabilities that are associated with a range of X values correspond to areas under the curve. So this probability that Z lies between -2.5 and -1 is this area, and that area happened to be 0.1525. And of course, the total area under the curve is 1. So we can look up areas to the left in table A2. We can also use Excel to find areas to the left. But if we ever want area to the right, we just have to use the complement. We're just going to subtract the area to the left from 1 in order to get the area to the right. Sorry about that. We're subtracting the area to the left from 1 to get the area to the right. So remember, when you're doing this, when you're dealing with um, normal distributions, including standard normal distributions, as we talked about in this section, areas correspond to probabilities, and that's actually true for any continuous probability distribution. But the areas in our tables are all areas that correspond to that standard normal distribution. So it's a normal distribution with a mean of 0 and a standard deviation of 1. So that's it for finding the areas or probabilities associated with a certain range of z-scores. In the next video, we're going to talk about how to find z-scores associated with known areas or probabilities. So we're just going to do it the other way around. I'll see you in the next video.